So all I'm doing, this is why the unit circle is really nice. You look at the unit circle and you say where is 360 degrees? 360 is here. And what is the sign there? Sign is y, the answer is 0. Let me take questions on how we got that. I'm going to do another example so we can see a little more. So we'll do problem number 10, cosine 7 pi over 6. Cosine of 7 pi over 6. Marvin, are we going to get at this board also when I come over here? No.
No.
Is it possible to see both?
No.
Tilt the camera a little bit. Hold on one second. So you come over here to 7 pi over 6, that's right here. You draw this angle, and we want the cosine, so we want the x value, so we want negative root 3 over 2. We want negative root 3 over 2.
You're never looking for the degree?
No, because it's asking the cosine of the angle.
So it's looking for the x values and y.
The x values and y values. If we wanted to ask the degree, we would say convert the angle to degrees. Okay, good question. More questions on this piece. Let's look at number 1 on part 2. So the bottom of page 1. Bottom of page 1. This will require people to do a lot of the exact same skill. So it says, problem 1 says that a student finds that the sine of 45 degrees is root 2 over 2. Sine of 45 degrees is root 2 over 2. And they've asked us to see what is the sine of 135, 225, and 315. Sine of 135 degrees $225. So I think everybody should be able to solve these 3. Go ahead and do that on your own. Go ahead and do that on your own. As you all do that, I'll just come and grab the homework. Let's go ahead and finish this part, this piece up. And once you get that, try to identify what is the pattern whenever I add 90 degrees. What happened here? And I hope when people did this, they got the following. Root 2 over 2, negative root 2 over 2, negative root 2 over 2. So the pattern is, Luis?
Wait, isn't it supposed to be negative? Yeah, isn't it supposed to be negative 1?
Which one?
Yeah.
Sine of a 225. So here's 225.
Oh, it's the other one.
This is 210. This is 225. So the sine of 225 is negative root 2 over 2. So the pattern is, well, the value doesn't change. We just become positive or negative depending on the quadrant. Positive or negative depending on the quadrant, value didn't change. You'll do some more work where you'll see what happens when I start at 30 degrees and add 90 every time. And you might see a different pattern. But that's for you all to figure out on the home. I just gave you one pattern. Okay, any questions here on this piece? Okay, let's go to part 2, problem number 3. Excuse me, problem number 5. Excuse me, number 5. Problem 5 says if the cosine of theta is 1/2, sine of theta is negative root 3 over 2, what is theta? So the way we want to think about this is the following. Start off by thinking this to yourself, and don't say this out loud, but think this. What quadrant does this angle have to be in? You want to think about that. What quadrant does this angle have to be in? Carla, what do you think? Quadrant 4, and why is that? But how do you know that means quadrant 4? Imagine this graph wasn't here. So it's not necessarily about increasing. Just what do you think? And now relate that back to cosine and sine. How does like x and y mean with cosine and sine? Luis, finish it off.
Cosine is x and sine is y.
Yeah, this is it, right? This is what we want. So we want the combination of all the answers, right? So Carla said quadrant 4, cosine positive, sine positive. Jessica added on. Well, in quadrant 4, the x values are positive, the y values are negative, and Luis finished it off saying cosine means x, sine means y. So I'm definitely in quadrant 4. So I'm in here. It's going to be an angle from here. Which angle is it going to be? Which angle will satisfy these conditions? Jessica? 300. You come over here to 300. There's the 1/2 for cosine. Here's the negative root 3 over 2 for sine. So the answer is theta equals 300 degrees or 5 pi over 3. Degrees or radians. We're going to push to get to radians. We're not there yet. That's fine. We're going to push to get there. We really need to be there by about next week. End of next week. Let's push to get there over time. So I'll always write the answer as well. Questions on how we did that? But I think it's worth going through the process of identifying the quadrant and then picking the angle. Okay. So I want to do 2 more things here before we get out of here. So, and then tomorrow you guys are going to have the whole day on your own for this. And if you need to bring like headphones tomorrow because you like work better with that, that's fine. Right? If you need to do that, that's totally fine with me. So here's what we need to do though. We need to look at questions like on part 3, number 1. Part 3, number 1 is very interesting, right? Because it says find the cosine of negative pi over 3. And this was a question that we had last Friday, and I said just hold it. Like, how do we have these negative angles, right? And that's what I want to talk about now. So the negative angles are really just a rule that you need to remember. That's it. If I start here at the x-axis and I go counterclockwise, like what we've been doing, go counterclockwise, angles are positive. So if I go counterclockwise, angles are measured in positive values. So I start at the x-axis always. We always start here. If I go counterclockwise, angles are measured in positive values. The flip side, of course, if I go counterclockwise, clockwise, the angles are measured in negative numbers. That's it. So let's write this. If I go clockwise, the angles are measured in negative numbers. Or negative, let me say negative values. Let me say negative values. Say negative values. And let me explain a little bit more what I mean by this. If somebody said negative 30 degrees. Somebody said negative 30 degrees. Okay, that means we start here and go 30 degrees this way. So we would end up right here. This line right here is negative 30 degrees. Start at x-axis, go clockwise. Notice that is exactly the same as starting at the axis and going this way. How much?
330.
330? 330? So negative 30 degrees is the same as positive 330. So it's the same as 330. Negative 30 is the exact same as positive 330. I get to the same spot. So, what do we mean by this? We mean the following. If we have a negative angle, all we do is add 360 degrees and we get the positive version. That's it. Let me write this down. If we have a negative angle, if theta is negative, then add 360 degrees, or, and I'll write or 2 pi, right? If the angle's in radians, we want to add 2 pi, not 360, to make the angle positive. David Torres.
Would you ever, will you ever make a question where you give to us the negative and want to send us the positive?
Yeah, we will. Or we probably won't give it directly. We'll probably give something like this where you have to make it positive and then find the cosine. That's probably what we'll do. So let's do this problem now. So are there any questions on the negative positive before I do this problem? Yeah, let's find out. I actually haven't done it. So cosine of negative pi over 3. Right? So what we need to do here is, because this is in radians, we want to add 360. So we want to add a 2 pi. Not 360, because then I have to convert to degrees, then add 360. It's all more work. Just add the 2 pi. 2 pi is the same as 360. Selma?
Is that a 0 or a theta? On the top is blank.
Yeah, theta. Theta. So here we go. I'm going to say negative pi over 3. I'm going to add 2 pi. Right? 2 pi over 1. Any number's over 1. So we need to get the same denominator. So multiply by 3, multiply by 3. So I have negative pi over 3 plus 6 pi over 3, which equals 5 pi over 3. Carla. Yeah. So I took negative pi over 3 and I said I want to add 2 pi over 1. I want to add 360 degrees. 2 pi is the exact same as 360. So 2 pi over 1. So I need to get a common denominator of 3. So multiply the top and bottom by 3. So 6 pi over 3 plus negative pi over 3 is 5 pi over 3. And now I need to find the cosine of this. Because they wanted the cosine of negative pi over 3, so I got to find the cosine of positive 5 pi over 3. Here's positive 5 pi over 3, just as Luis said, 300. The answer, 1/2. So the answer to this question is 1/2. Questions? Jenny? For cosine. If it had asked for sine, why? Questions? Jump in.
For explanation, if you try, it's always pi over x.
Pi over x.
That one.
2 pi over 1.
Oh, there's the x.
No, but then I crossed it out. I made it a 3 because I had to get the same denominator. All right. So just one last thing. One last thing. Let's look at a problem like. Let's look at something like number 2. Number 2. On the same part, just right below it. Can we come back over here, Marvin, if you don't mind? This is asking what is the sine of 660 degrees? Need everybody with me here for the last few minutes. Need everybody with me. Sine of 660. Now, this angle is bigger than anything on the unit circle. We stop at 360. I think the best way to think about this is in basketball terms. We imagine LeBron James does a 360-degree dunk. Maybe we'll watch a video tomorrow. Right? So what does he do? He goes up for the dunk, he spins once, and then he dunks it. That's 360. What if he did a 720-degree dunk? He would spin twice in the air and then dunk it. So angles above 360, all we've done is we spin once and then a little bit more. So if we think about it in terms of the unit circle, an angle above 360 means we did this. There's 360. And then we did a little bit more. And maybe we did 2 more times. All it means if it's above 360 is I completed 1 revolution or 1 complete circle, and then I did some more. David?
Would it still give you the X and Y value?
Yeah, so let's see how we do that. So for angles above 360 degrees mean we have completed more than 1 revolution. A revolution is going around the circle 1 time. Think about the LeBron James 720-degree dunk. Maybe the people who play me on a 2K can try to do that. So, how do we solve this? How do we get this angle back on the unit circle? We subtract 360 or 2 pi. So, if an angle, or if theta is too big, and by too big, what do I mean?
Bigger than 360.
There we go. Above 360 degrees, then subtract 360 degrees or 2 pi. Right? Or 2 pi. If it's already in radians, don't need to convert and then debug. So how do I do this problem? Well, 660 minus 360 equals 300. So they're really asking for the sine of 300. This is money in the bank. Come over here. 300 right here. What is the sine? Negative root 3 over 2. The test next week will be money in the bank if you can draw the circle. If you can draw the circle next Thursday, you can make 100. It is that simple, folks. It's that simple. The circle, the unit circle, determines an A or an F. Have fun, folks. I'll see you tomorrow. Good job.
The rest of us going for the
Bye.